Okay, I guess we're ready to roll here. That's pretty cool. So in the next hour, I'm going to talk a lot about vCenter performance. I'm going to talk about more or less how 6.0 looks and how you can get the best performance out of your deployment. And I have two other names on this slide, Dilpreet and Zilong. To be honest, a talk like this and the work that went into improving vCenter is the work of hundreds of people, and I'd be remiss if I didn't acknowledge all of them. I put these two names here, but a number of folks helped with this, and I can't take credit for all of that. All of them deserve a lot of credit. So with that preamble in mind, let's talk about vCenter. So basically, my layout for this talk is I'm going to try to do a deep dive into vCenter architecture. Hopefully, with that understanding, we'll be able to dive into factors that influence vCenter performance, and then we'll talk a little bit about various deployment options and what might work for your setups. Now, I wanted to start this talk off with a teaser. For those of you that are on 5.5 and are looking for reasons to upgrade to 6.0, from a performance perspective, here's one set of reasons. On this chart, I show throughput in terms of number of operations per minute, and I show it for 5.5, which is in dark blue, and then I show 6.0, which is in light blue. And as you can see, for a small inventory, which is on your left, and for a large inventory, the throughput in 6.0 is significantly higher than in 5.5. So from a performance perspective, 6.0 is superior to 5.5. I'd also like to point out that that was from an operational throughput perspective, but from the perspective of the web client performance is also dramatically improved between 5.5 GA and 6.0. Now, we have put a lot of changes into the web client in 5.5 U2B, if I'm not mistaken, but the point is that between 5.5 and GA and 6.0, the web client performance is dramatically better. So throughput is better, web client performance is better. I really hope that these are reasons to help you convince your boss to upgrade to 6.0. So now the agenda for this talk is that I'm going to first talk about vCenter. I'm going to try to do a deep dive into vCenter components. Then I'm going to talk about various factors that influence performance. After that, I'll talk about various deployment options, and then I'll conclude. So for most of us, when we think about vCenter, and this was probably true even when I joined the company about 12 years ago. Oh, by the way, my name is Ravi Sandarajan, and I'm a principal engineer in the performance group, and I've worked on vCenter since 1.0. So for many of you, this is what vCenter looks like. You got a couple of clients, whether they're C#, web client, some extension, whatever. It talks to this service called VPXD, which has some back-end database that backs it up. And that right there, that VPXD is the vCenter server, and that's what you think of as vCenter. Now, that's the idealized view. Reality is quite a bit more complicated. And in the next hour, don't get scared, don't worry. In the next hour, I'm going to deconstruct this so that it makes sense to all of you. I should also point out that these slides are going to be available later, so you don't have to hurry to take pictures. You're going to be able to get them later. Okay, so let's go ahead and dissect it. So, at a very, very high level, vCenter is comprised of single sign-on and identity management. It's comprised of a web client piece. Obviously, there's a VPXD component or workhorse component. We'll talk about that a little later. There is an inventory service, and then there's a number of other services. You may have heard that between 5.5 and 6.0, we've added a number of services, and I'm going to describe what a number of those do throughout this talk. So this is the very high-level picture, and I'll dive into this. Now, the first thing you'll notice when you move to 6.0 is that the installation experience is slightly different. In 5.5, we gave the option to install all of these different pieces on different hosts. And in 6.0, we encourage you to install, or rather, all of the components are to be installed on the same machine, except maybe SSO and platform services. And I'll talk about that later. So the point is, single place to put everything. We're consolidating all of our components onto a single server. Okay? So with that as a backdrop, let's talk a little bit about these pieces. So I mentioned that the first piece is single sign-on or identity management. I'm going to call it SSO. And as many of you probably know, it's probably redundant. SSO is responsible for providing a global view of roles and permissions. It's also obviously responsible for talking to Active Directory or whatever other identity sources that you have. And it's also responsible for letting users that interact via the web client have a global view of anything that is registered with that SSO server itself. So as you can see here, I have a number of different roles permissions that are global. And when we think about the web client and how it allows you to view multiple things, the way it works is that when I log into this web client service, which is installed in the vCenter server. That web client server talks to SSO, finds out everyone that's registered. Once it authenticates, it can now see everyone that's registered with that SSO server. So as you see here, I have two vCenter servers, and I can see them from the same place because both of them are registered with the same SSO server. So when we think about the installation of vCenter, we've installed SSO. Now we've installed the web client server piece. The next piece is, frankly speaking, the most important piece perhaps. It's VPXD, or the vCenter server service. VPXD has a number of different tasks. Basically, it's responsible for the main business logic of your system. So, for example, when you power on a virtual machine, you interact through the web client. The web client service talks to VPXD, and it says, I want to power on this VM. VPXD is responsible for finding the host where the VM is located, telling it to power on the VM. Once the VM is powered on, the host comes back and tells VPXD, okay, I'm done. And VPXD takes the changes that have occurred because of that power on, and it pushes them into the database. VPXD is also responsible for persisting statistics data into the database, and it basically does this every 5 minutes by polling different groups of hosts, grabbing statistics, putting it into the database. So essentially, any task flows through VPXD, stats information flows through VPXD. Okay? And in addition, if you've got extensions that are connected to vCenter, for example, VROps, or if you have some sort of custom API client that you've written, those requests go to VPXD and it satisfies a lot of those. Okay, so it stores the inventory and it does workflow management. So that's VPXD, and I mentioned that it persists statistics data as well as configuration data and changes into the database. Let's talk a little bit more about the database. So in addition to persisting statistics data, the database by itself performs a number of statistics rollups. Many of you are aware that vCenter stores statistics at multiple granularities, past day, past week, past month, and past year, and the roll-up from past day to past week to past month, or past month to past year, that occurs through scheduled tasks that occur within the database, and what we call these roll-up tasks. In addition, when you have a past day statistic and it's been in the database for longer than a day, it gets purged. That purging occurs automatically within the database. In addition, if you've set up your events to automatically purge after, say, 30 days, 60 days, or 90 days, the database is responsible for that. If you set up tasks to automatically purge after a certain amount of time, that's handled by the database. And finally, we have a number of charts in our client that show you the top 10, say, VMs by CPU usage or VMs by memory use. And those are computed in the back end or in the database by what's called the top end stored procedures. And those operate at 10-minute, 30-minute, 2-hour, and 1-day granularities. Now, the reason I'm putting this up is that if you're ever looking at your database and wondering, why am I seeing spikes every, 30 minutes, 2 hours, whatever, hopefully with this chart you'll have some insight as to what's going on even when your system is idle. And if you happen to want more information, in previous VMworld talks, I go into that in a bit more detail. Okay, so we've talked about SSO. We've talked about the web client service, which lets you talk to SSO. We've talked about VPXD, which lets you perform tasks. We've talked about the database, which is where we store statistics, tasks, events, and any configuration changes that occur on my hosts. Now let's talk about a piece called the inventory service. The inventory service, basically, it's another web service that sits within our vCenter server, and it's primarily responsible for caching inventory information. Basically, it's an embedded database. And what that embedded database does is that it allows vSphere web client queries to go from the web client server to inventory service, so it satisfies those requests so that such requests for inventory data don't have to go to VPXD. So it's kind of offloading inventory queries and other sorts of queries. So in that way, it reduces the load on this core VPXD server, and it lets the VPXD server focus on what it does best, namely task execution. Okay? So, like I said, if you have the web client, most of your queries from the web client are satisfied by this inventory service. In addition, many of our partners put information in the inventory service, and those kinds of queries are also satisfied by the inventory service. Now, this separate piece, by putting a little bit of data inside this inventory service, it allows different extensions to automatically show up in our web client. So it's a good way to allow second and third party integration. And to give you a simple example, I show you that VROps puts a little bit of information in the inventory service, and as a result, this automatically shows up on the web client page. So this is one advantage that having something like an inventory service helps us do. It's a slightly easier integration point. So like I said, it's an embedded database. It stores essentially a copy of the vCenter inventory, so it reduces the load on your VPXD service and on your main relational database. And it allows seamless integration with other products. Now, having said that, it is an embedded database, so when you deploy this, you have to be mindful of its memory and I/O resources, and those are pretty key to high performance. And I'll talk about those a little bit later. Okay, so now we've talked about this much of the vCenter server. We've talked about the web client service. We've talked about VPXD for doing tasks. We've talked about SSO for identity management, etc. And we've talked about the inventory service, which caches inventory for various web client requests. Next, we're going to talk about some of the other services that are available. There is a service called SPS, or a storage profile service. So if you're using storage profiles, if you're saying bronze, silver, gold, whatever, those profiles are stored and processed by this storage profile service. We also have various health services. We have health services not just monitoring the health of our hypervisor hosts, but also health services that monitor the vCenter health and the health of the various services like the database and like a lot of the services that I'm listing here. We've also got a service called perf charts. So if you've ever gone to the web client, you'll notice that there's an advanced, if you look at the performance tab for a VM or for a host, there's an overview tab and there's an advanced tab. The overview tab has a bunch of pictures of different performance charts. That's driven from this perf charts service. We also have a content library. This is, I guess, new in 6.0, but now, so if you want to create a repository of VMs or other different kinds of files and share them across different instances, you can put them in this content library. And my colleagues wrote a nice blog talking about how to use this content library more efficiently. So now that's inside of vCenter as opposed to being a separate component. And we have a number of other services. In a fully embedded configuration, you'll have licensing, and for example, but some other services that we have include, we have a workflow manager in case you want to insert items into, say, a power-on workflow. We have various proxy agents so that you don't have to remember the endpoint of every single service when you're writing an API client. And if you're deploying something like NSX, the VMs that help manage NSX are called agent VMs, and they require different policies from other VMs, and so we have services that do agent management. So with that, now you have a good sense of what many of these services within vCenter do. And sometimes if you're running at least vCenter on Windows, you might be wondering, what's my server doing? What is the resource utilization? And for that reason, I'm going to walk you through the next few slides. So if, for example, I'm running vCenter Windows and I'm wondering what are these services are doing, I might pull up Task Manager. And I would see a lot of Java services, and I'd think, what on earth is going on here? So just to give you some insight here, many of our services, what I do here is I sort all of these services by memory usage, for example. And what I like to do as a first cut is I first look at the username for the Java process. And that often gives me a clue as to which service it is. So in this case, this is the web client service because its username is vSphere web client service. This other service, its username is VDCS. It's a long story, but that's the content library and transfer service. Okay? Remember, you'll get these slides later, so you don't have to remember all of this. Now, this username approach helps for some of the services, but it clearly does not help for all of them. For example, this service, PID 2504, its username is system. What are you supposed to do to figure that out? What I like to do in situations like this is I like to use Windows sysinternals. So I install sysinternals, I take that PID, and then I look at the process tree, and I find the wrapper function that called that process. And when I do that, I can look at the path, and the paths are rational, so you can look at it and say, okay, here, this is VMware STS, that has to do with identity management. So if you install Windows sysinternals, you can use this technique to figure out what each of those Java services are in Windows. And it can help you understand the relative memory usage of each. Now, as a bit of a plug to maybe use the appliance, in the appliance we have a special tool called vimtop. For those of you that are familiar with Linux, it's similar to Linux Top. And as you can see, what we show here is we show the names of the various services, and we also show resource utilization information for each of them, CPU, memory, number of threads, etc. So if you're using the appliance, we have similar techniques for resource tracking that we have in Windows. In order to enable this view, I should point out you have to enable SSH and troubleshooting mode. Assuming you've done that, this is one way to monitor resource usage in the appliance. Okay, so with that, we went through that huge picture of vCenter, and we did a bit of a deep dive into what the pieces are. Hopefully you have a good understanding of that. We talked a little bit about some of the resource monitoring tools we have. Now let's talk a bit, given that information, about what sorts of things influence performance. So, it's probably not a surprise, but given our architecture, the number one key to performance tends to be resource usage, resource provisioning. What I've done here is I've basically taken our documentation and I've listed the minimum system configurations for our small, medium, and large setups. You can go ahead and read them there. It's straight from our documentation. I should point out that you should treat these as minimum. And I should also point, well, I have small, medium, and large, but for those of you that like to test this at home, we also have a tiny configuration. So that's a nice thing to do if you have a smaller footprint. Now, I should point out that I'm calling these minimum, and the reason I'm calling these minimum, as you're going to see in the following slides, is that your performance varies quite a bit depending on various environmental setups, how many extensions you have, what your inventory configuration is, how many vCPUs, disks, networks, etc. And so view these as guidelines, and hopefully the information in the next few slides will help you plan your environment a little bit more rationally. So at a very, very high level, what sorts of stuff influences vCenter performance? I sort of distilled it down into 4 different factors. Of course, there are many. But the first is churn. In other words, how many operations are you doing against vCenter per unit time? Okay. And I should point out that for the bulk of you, out-of-the-box settings should work fine. But I'm just going to, for the sake of completeness, go over different options here. The size of your inventory and the configuration of your hosts and VMs matters. In addition, the number of different extensions or plugins you have installed matters, whether you have VRA, VROps, or other third-party things. And in addition, what you decide to set as your statistics retention level and your task event retention level, those things also influence vCenter resource usage and performance. So let's take a look at these, and let's take a look at these in the context of the different resources we have available to us: CPU, memory, disk, and network. Okay, so we're going to examine these under different sizes of inventory and with different churn factors. So the first thing I want to do is show you the impact of your inventory size on CPU usage. So what I'm showing here, on the x-axis, I have the number of ESXi hosts, and on the y-axis, I have the CPU usage. So this is on a scale where 0 to 70 means 70% of one CPU. If it were, for example, 700, that would be 7 cores, etc. So your mileage may vary, I should point that out, but what this shows me is that the resource usage varies more or less linearly with the number of hosts you have connected, number one. And number two, if your system is idle, in other words, if you're not sending any tasks to vCenter, the resource usage is relatively modest. You're talking about less than 1 core if you've got 1,000 hosts and if nothing is going on in your system. So, like I said, depending on your configuration, these will be different, but this can give you some rough guidelines. If you're wondering, well, how does this impact with the number of VMs, etc., this is a good view. Now, one thing I will point out here, the way I varied the number of hosts and VMs. I varied the number of hosts in this chart from 100 to 1,000, and on each host, I have 15 VMs, 10 of which are powered on. I've kept that form factor as I've increased the number of hosts. So bottom line, CPU usage more or less linear, and it's for an idle setup, it's very modest. Let's now introduce churn. Okay, in this chart, again on the x-axis, I have the throughput of vCenter. So how many operations per minute are you pumping through vCenter? And on the y-axis, I have CPU usage. The big thing I wanted to highlight here is, perhaps not surprisingly, the CPU usage of vCenter is critically dependent on how many operations you try to put through. In the case on this particular chart, I needed about 7 cores to get 700 operations per minute. And if I wanted to get 1,600 operations per minute, I needed 16 cores. So clearly, the more load you have, the more CPUs you have. I should also point out that this is for our at-scale environment. So this is for the 1,000 host, 10,000 VM setup. And I'm trying to do this experiment. I do this experiment using SSDs because I want to make sure that disk isn't my bottleneck here. So bottom line, this helps you understand the impact of CPU on your performance of vCenter. Now, it's perhaps not surprising, but the different CPU versions can also impact performance. So unofficially, when we've done experiments in-house with, for example, the Haswell class processor versus a Westmere class processor, we've seen up to 60% improvement in our throughput. So if you're looking at a refresh cycle and you're thinking, does vCenter benefit from a faster CPU or from a different architecture? It absolutely does. Okay? So that's CPU. Now let's take a left turn and talk about memory. So in this chart, what I'm showing you again on the x-axis is the number of ESXi hosts I have connected, and on the y-axis I have memory usage in gigabytes. Okay? And in this particular case, what you can see, of course, is that after some fixed cost for an inventory, memory usage is roughly linear with the number of hosts and VMs that you have connected. In this case, for my 1,000 host setup, it's taking about 18 gig. I want to point out, memory usage is critically dependent upon inventory size. That's probably the #1 factor, okay? And I want to contrast that to what happens when I put a load on my vCenter server. So in this chart, what I'm showing you is vCenter throughput in terms of operations per minute, and again on the y-axis, I'm showing you memory usage. Now this time, what I did was I ran an extremely high churn workload twice. Okay, the first run of the workload is the line that ramps up. Once I finished, I run it again. What you can see is that once you've cached about a bunch of information inside of vCenter, the memory stays roughly fixed. So what you can see is if you're trying to figure out, well, I have a high churn environment, which is more important, inventory churn, whatever, what we typically see in-house is increasing the size of the inventory often has a larger impact on memory size than the workload that you impose. Okay? And again, these experiments were done with SSDs. Now, when you're looking at that task manager chart in Windows or at Vim Top in Linux, and you're wondering what are the top consumers of memory, let me give you a little bit of intuition as to what you might expect to see there. So the top consumer of memory is typically the inventory service. Again, it's caching your inventory, and so as a result, it depends on your inventory size. And next is the VPXD service. We all know that that has a bunch of inventory information cached, and it also performs a lot of tasks. And as a rule of thumb, if you're looking at your memory usage, VPXD and your inventory service are typically of the same, fairly similar. So if your VPXD service is 8 gig, you might expect your inventory service to be 8 gig, something like that. If those are radically out of kilter, I'm not going to say something is wrong because your environment may vary, but that's just something to think about and look at. The next one is typically our storage profile service. It stores a lot of information about different items in your inventory, so it varies with the inventory size. After that, the vSphere client service, remember the one that interacts with the web client and satisfies those requests, that's typically next. And the memory usage of that depends on the inventory size and critically on the types of extensions you have, whether it's VROps, NSX, whatever. And then in the top 5, the 5th one is usually this content library and transfer service. And in contrast to the other services we have, the memory usage of that is going to vary based on the number of concurrent transfers that you're doing and stuff like that. Now, for the ones that are Java services, on this page, everything except for VPXD, their performance is critically dependent upon their heap size. And luckily in 6.0, we've made that a lot easier to deal with. So if for the sake of argument you want to look at the heap size, I'm going to go through this for the appliance and then I'm going to go over it in Windows. And luckily they're exactly the same. If you want to inspect the heap settings, I give you the command right there, cloud VM RAM size -j and the service name. Again, you're going to get copies of these slides later so you don't have to hurriedly write it down. So that's the heap settings for every single service, or for a given service. If you want to see the memory that each individual service is taking up all in one list, you can do cloud VM RAM size. Okay, that's the overall memory, not just the heap. And when you do that cloud VM RAM size, you get a picture exactly what I've seen here. And I double checked, the ones that I put as the top 5 on the previous slide end up being the top 5 in this one. So that's kind of, so they align. One thing I didn't put in is the database, and depending on whether that's embedded, for example, on the appliance or external in Windows, that memory usage will differ. So this was for the appliance. For Windows, it's exactly the same command. You just have to find the right path, and the output looks exactly the same as well. So we don't need to go over that in more detail. What I would like to point out is that on the previous slide, what I said that many of our services are Java services, and I also said that performance is dependent upon heap size. Now, out of the box, we've done a lot of tuning in this release, so hopefully the out of the box settings will work. If you notice performance issues and you're looking at a chart like this and you're thinking, gee, it looks like it needs more memory, you have two options to increase the heap size of a service. The first one is by far the easiest. Unlike 5.5, in which you could add more memory to the VM and then reboot it, but then every service had the same heap size that it had before, in 6.0, if you add more memory to the VM and then restart the VM, all of the Java heaps get automatically resized. So a quick way to increase the heap sizes is simply to add a little bit more memory to your VM, reboot, and then you're done. Very, very simple. If you happen to want to resize an individual service, you don't have to reboot the system or anything like that. You use the command that I've given at the bottom of the screen, Cloud VM RAM size, with a couple of options, and then simply restart that service. So if it's not an option for you to increase the amount of memory on your VM, but your VM has plenty of memory, it's just this service that you want to give more memory to, go ahead and increase that service individually. Okay? Now, it's probably obvious, but it does bear sort of emphasis. If you give vCenter more CPU and more memory, and if you make sure that the I/O subsystem backing it is well balanced, you're going to get better performance. Like I said, that sounds obvious, but bear with me for a minute and I'll explain why it's not obvious. In the chart below, I show you for vCenter 5.5, for 6.0 Windows, and for the 6.0 appliance, the impact of adding more CPU and memory. The dark blue chart is 16 vCPU, 32 gig, or basically our large configuration. The light blue chart is when I've given it 8 more vCPUs and 16 more gig of RAM. What you see is that in 5.5, there's a small difference in performance if I give more resources. But in 6.0, whether you're running the appliance or whether you're running Windows, we've made a ton of concurrency optimizations underneath so that you can take better advantage of CPU and memory. So, as I've said, vCenter now benefits from faster CPUs, it benefits from more CPUs, it benefits from more memory, etc. Again, this is an system that has SSDs, so you want to make sure that even if your CPU and memory are fast, that you're not being bottlenecked on the back end. Okay? So, we've talked at length about CPU and memory. I would say that when I look at customer setups, the kinds of problems I see in some order are basically that memory usage is a bit high, or that disk I/O is a problem, whether it's disk I/O to the database or perhaps the inventory service, and then CPU comes in next. Now we understand the factors that influence CPU and memory. Let's talk a little bit about disk, and then after that I'll talk about network. So, I'm going to give you a sample chart. In this chart, it's going to show you the I/O breakdown for a setup that I have which has 64 hosts and 8,000 VMs and is running about 300 operations a minute. Now that's a pretty high churn environment relative to most customer standards. I say that the largest customer setups I typically see are in the order of, say, 20 operations a minute, so this is quite a bit more than that. And I also am going to point out that this is using the default stats level of stats level 1. If you were to plot kilobytes per second, on the x-axis is time, and on the y-axis is kilobytes per second, you'd see a chart like this. Okay, and what I've done is I've broken it down by the various partitions that we have in the vCenter vCenter appliance. So don't worry about the specific numbers, just worry about the shape of this curve. The point is, under a constant churn, what you see is that database data and database transaction log is about half of your I/O. Okay, so database data would be when I'm doing operations and I'm updating VM config, host config, etc. That's there. The transaction log is for obviously doing write-ahead logging or whatever for those things, as well as issuing transactions for statistics, etc. Now, I should point out in this chart that we not only have database data, but we not only have the relational database, but we also have inventory service I/O. In this case, I've taken a vCenter appliance where everything is on the same box, and I've broken down the I/O. So you can see that inventory service is quite a bit of I/O there. Now, one small piece that's not shown prominently here is the statistics database. We also put that on a different partition. The higher the stats level, the larger that contribution is. So under extremely high churn, you'll see the database and inventory service take a lot of disk I/O. And in this case, for this particular experiment, it's around 3,000 IOPS. So why am I putting this up here? The precise numbers aren't nearly as important as having an understanding that, okay, I need to make sure my database is on fast storage. I need to make sure that my wherever I deploy vCenter, because it's got this inventory service inside, this has to have a good I/O subsystem backing it. And it also, as I can give you some tools to plot this sort of stuff later, but you can also look at statistics and see what its breakdown is as well. So, Database is important, inventory service is important. These can generate a lot of IOPS, so be prepared for that sort of thing. In the past, when we didn't have an inventory service, we didn't have that cache, people might install vCenter on one machine and their database on another machine. And for vCenter, the only thing that wrote to disk was say, logging, and so that wasn't a lot of I/O. And what I'm trying to emphasize here is that given that it's got an inventory service and an embedded database, it can generate a non-trivial amount of I/O. And so you want to put it on a subsystem that can support that I/O so that you don't have performance bottlenecks. Okay? Now let's characterize this traffic a little bit more. As you can probably imagine, it's related to the size of your inventory and the statistics level and the amount of operations that you put against it. The main relational database, okay, the database, vCenter database, obviously it depends on the workload, the inventory size, the stats that you're putting in and the sorts of events that you're gathering, and anything else that you're attaching to vCenter. So let me give you an example here. Imagine I have an agent that logs into each of my ESX hosts every once in a while to do something, okay? Every time it logs in, it generates a vCenter event. That event goes into the database. So if we're ever in a position where you're wondering, why is my vCenter database events table so large, and you see a lot of user login, user logout events, well, maybe that's why. The point is a lot of these things go into your database, and so it's important to understand what you're attaching to it and what kinds of events that generates, because those things go into the database and can take up space. For the inventory service, remember the inventory service is merely a cache of your inventory. Okay, so it varies with the workload and the inventory size, but it doesn't, the statistics level or events or anything like that don't impact the inventory service size. Okay, and the database basically, as you saw from the deep dive earlier, it's involved in most operations. So the latency to that database and keeping it a low latency connection is pretty key. Now, we've talked a little bit about the structure of I/O. We've talked a little bit about its characteristics. Let's talk a little bit about some concrete numbers here. So what I'm showing you here, on the x-axis is the number of ESXi hosts. On the right y-axis, what I'm showing you are the transactions per second. And on the left y-axis, what I'm showing you is the bandwidth. What I wanted to illustrate here is that disk I/O is a function of your inventory size. Not surprisingly, you're persisting more statistics in the database, you're keeping a bit more configuration, and while the demands here look relatively modest, it's also, I should point out this is an idle setup, but the point is that when you're idle, you're not generating a lot of traffic, but you should still be mindful of this because once you start imposing load, these numbers change. Okay? So roughly linear change. Now that was a completely idle setup. Now let's talk about a setup in which we impose a load. We again have now we have the throughput in terms of operations per minute on the x-axis, and again on the right y-axis we have transactions per second to disk, and on the left y-axis we have bandwidth. And the thing I wanted to illustrate here is that as you increase the number of operations per minute, the throughput that's required of the database roughly increases linearly. Again, this is an SSD. We can support the kinds of operations that we're putting here. If you're using a higher latency disk or one with less bandwidth, you're going to see different numbers. And one of the reasons I show you here is that as you give capability to your disk subsystem, you can expect your performance to improve. So what I'm showing you in this data point is that to sustain 700 operations per minute to my vCenter server, it's taking, I don't know, 20 megabytes per second and 1,500 IOPS. So be prepared for that. When I try to double that, I roughly double the disk usage that's required, and I roughly double the operations per second that I have to sustain. So as you're building out your system, make sure to make it a well-balanced system in terms of CPU, memory, and disk. So what are the kinds of things, what are some other considerations that are there? One thing I want to point out is that most of our traffic tends to be write traffic. If you think about the sorts of things that you're doing, you're inserting traffic, and you're inserting stats or events or tasks into the database, you're updating their status, you're rolling up statistics, you're doing configuration updates. All of those are basically writes, and so be mindful of that. The data traffic pattern is, for the logs, obviously it's mostly sequential, but for the data, it's mostly random. So you need a disk subsystem that can handle that sort of thing. Now, I've said this many times, I hate to keep harping on it. It's not that you need SSDs, but just in our own internal testing, SSDs provide a substantial performance improvement relative to magnetic storage. If you have a very, very beefy, highly rated array, you can get obviously you get good performance as well. But for us, low latency has enabled us to demonstrate these kinds of gains. I mentioned that most of the traffic is write traffic. It turns out that we do have some fraction of read traffic, and usually that read traffic is captured entirely in memory. So if you increase the amount of memory that's available to your database, or in fact to your vCenter, you can capture more read traffic there. It's not going to help you for writes, which is why I talk about having a lower latency pipe so that you can absorb the write traffic efficiently. In terms of stats level, I'm going to talk about that on the next slide, so let's hold our thoughts for that for a moment. Now, in terms of the physical disk configuration, so here's where the appliance and Windows differ. In Windows, you can choose where you want to install it in terms of the partition, but everything gets put in one place. Okay? In the appliance, we have a number of different VMDKs that are split out by function, so you can independently put each of those VMDKs on separate partitions. I've already given you the hint that there's a database log VMDK that you should put separate from the database data partition, which you should put separate from the seat, or statistics, events, alarms, and tasks data. And so those should also be separate from the inventory. So the point is that each of these, if you have the capability, separate those databases that I've just mentioned onto separate spindles and partitions. Within Windows, while everything is in the same appliance, you just want to make sure that you've got the backing underneath that can handle the kinds of traffic patterns that we're talking about here. So use stripe disks or SSD or something like that to try to accommodate the churn. Another important thing, which I'll talk about in the next slides, is talking about the growth of your database, what data goes in it, like events and tasks. And there's also obviously a trade-off in terms of I/O as to where you put the database. Do you embed it with your vCenter server, or do you put it separately? We'll talk about that in a little bit as well. So first, let's talk about stats level. So your mileage may vary because the number of statistics that you persist in your database depends on how many vCPUs, how many disks, how many networks, how many NICs, how many of a lot of different things are connected. And so there's, I don't know, maybe 700 people in this room, and there's at least 700 different environments that we have. As a rule of thumb in my setup, and this is just to help you understand the order of magnitude that we're talking about here, for level 1 statistics, these are the coarsest grain, and these are just per VM and per host aggregated statistics. When you increase that to stats level 2, you could see up to a 4x increase in the amount of stats that you're persisting to the database, and therefore to the amount of traffic you're seeing in your network. So just be prepared. If you're moving your stats level, that's what you might see at level 2. Something like level 2 is just a few more stats that are per VM and per host. Level 2 to level 3 is where the largest jump typically occurs, because at level 3, now you have per instance statistics, per vCPU information, per data store information, etc. And you'll find that then, with the more data stores you have, more VMs, etc., now you increase the number of stats that you're persisting by a substantial amount. And this is one reason that we encourage you to use a lower stats level, because once you increase to this level, you end up seeing a large increase, and you have to make sure that your backing subsystems can handle that. Level 4 just adds a little bit more stats over level 3. The jump is quite a bit less, only 1.4, something around there, so not much more. So the big jump is from 2 to 3 typically. So what I recommend is we have the stats calculator within the vCenter UI. You can use that to estimate how much disk space you're going to need. That doesn't talk much about I/O. That's what I'm showing you here. On all of the previous I/O charts that I've shown you, they've all been with stats level 1. Now you can look at something like this and kind of guess, okay, my stats partition will be this much higher if I change it to level 2, 3, and 4. So that gives you some insight there. And like I've said this many times, try to use the stats level that's relevant to your use case. If you find that there's some statistics that you need that aren't at stats level 1 or that aren't at that stats level that you're using, please come talk to me later. And we can try to talk to the product management teams or whatever to figure out whether we can elevate those statistics. We often say that maybe you can, if it's an option for you, maybe consider VROps if you want to take the data out of the vCenter database and put it somewhere else. If that's an option for you, then that might be one way to lower your stats level and still get the statistics that you need. I've talked many times about the latency to the database and why that's important. And we have a good understanding of why now, because we know that every operation that I do has to persist something to the database. Whenever I want to get stats or persist them, it goes to the database. What I would recommend, so first of all, the vCenter and the database should be very, very close together, definitely in the same geography, if that's practical. I would go even so far as to say that if you have enough resources, if you have enough CPU, if you have enough memory, and if you have a sufficiently strong disk subsystem behind you, put them in the same VM. If that is not an option, or if you want to independently tune the database size, put them in different VMs, maybe put them on the same host as long as the host has enough I/O. But either putting on different hosts is fine. There's a little bit of a change in performance as you go. Those changes, the impact of that typically is more relevant at really, really high churn. So let me give you an example. In my own internal testing, I sort of varied the latency to the database, and when I got beyond 10 milliseconds, I started noticing a difference. Now, having said that, that was for a very high churn workload. Most customers are going to have it within 10 minutes. They're not going to notice any difference. And we've even noticed internally that if you go from having it on the same machine to having it on a different machine, but even on the same host, you can see a slight performance difference there. For most of you, that's not going to be important, but I'm just stating it so that you'll sort of have a mental model of what sorts of things to look for. Again, good to put the database and vCenter together, but only good if you have the resources behind it to back it. And I really hope that I've given you some guidance as to what's necessary there. The other thing I wanted to point out, I talked briefly about database growth. If you were to look at our database, more than 90% of the data is what we colloquially term seat data. Statistics, events, triggered alarms, and tasks. Okay, this is data that's basically time series data that grows with time. So these are the partitions that are typically going to grow, and the way to control the growth of these is to set the stats level appropriately and to set retention intervals for your events and tasks. I believe in 6.0, the default retention time for events is 30 days, which is fine for most environments. That is to say, it's not going to put an undue load on the database. If you have to increase that for some sort of compliance reason, just be mindful that you might have to examine the disk I/O to that partition more carefully. And that's what I mean by utilizing automatic event purging. Make sure that you set a retention interval there. There are some tables there are many tables, I guess, that are highly volatile. We tried our best to limit the impact of those. A couple of them, like the top end tables, might be ones where you have to recompute your database statistics once a day or even slightly more frequently. Basically, just keep them. Your DBA typically looks at hot tables and tries to figure out which ones need to be reindexed. We think we've optimized a lot of those. If there's something we think we've missed, please come talk to me and we can help you with that. So we've talked about CPU, we've talked about disk, and we've talked about memory. Let's talk about the final piece, network. So, network is obviously responsible for taking, whenever I do an operation on a host, I send an operation to an ESXi host, the result comes back, it goes into the database. So there's networking involved in sending commands, getting data, putting data into the database. If you've ever looked at your network traffic from vCenter, it probably looks something like this. It tends to be bursty. And what you see is that here, if in an idle setup, I'm periodically exchanging information. So on the x-axis is time, by the way, and on the y-axis is megabits per second. And you typically see some periodic transfer of information. Basically, an ESXi host talks to vCenter and says, hey, I'm okay, here's what's changed, whatever. And every 5 minutes, vCenter picks a different set of hosts and grabs statistics information from them. Okay, that's why you see these periodic 5-minute spikes. Now, it turns out that in 6.0, we also do a little bit of pre-caching of statistics. And so actually, every 20 minutes, you'll notice a big spike as well. I didn't put that on the slide, but it's there. Remember that these network spikes will depend on your stats level. If you're at stats level 1, it'll obviously be smaller than 2, 3, and 4. Okay, so now you understand the structure of this particular chart. If you want to know, roughly speaking, how the bandwidth consumed varies as a function of load, what I'm showing you here, I show you throughput on the vCenter throughput on the x-axis, so how many operations per minute it's doing, and on the y-axis I show the network bandwidth consumed, and I split it down into the sent traffic, the received traffic at vCenter, which is quite a bit larger, and then the total. And the point here is that, as you can probably imagine, the network traffic is clearly a function of load, and it's also a function of inventory, although I haven't put that here. But the more operations you do, the more traffic you're going to see. But even at very, very high churn, even if you're doing thousands of operations per minute, the network bandwidth demands tend to be fairly modest. In this chart, what I'm showing you is that for 1,000 operations per minute, you're at about 200 megabit per second. Since most of you have gigi as a minimum, typically network isn't the limiting resource. Having said that, that's from a bandwidth perspective. Latency is extremely critical. On this chart, I'm going to show you an example. So on the y-axis, so this is for a power on. Okay, power on operation. On the y-axis, it's the latency of the power on. It happens to be the median power on latency for a number of power ons that we did. On the x-axis, I show a number of configurations. Okay, I show configurations ranging from 10 gigabit per second. So the far left is basically the link from vCenter to the database. Sorry, from vCenter to the hosts. Okay, and in the one case, it's just within some LAN, and in each case, I vary either the throughput or the latency between vCenter server and the hosts. okay, and the bandwidth. I want to highlight two things. It's a big chart, and I apologize for that, but I want to show you two things. Oops, I wanted to show you two things. Let me show you that real. Okay, take a look at the bar on your side. It would be the far right. What I've done from the next to the last bar, whose median latency is about 12 seconds, to the far right bar, which is 26, is I've varied the latency from 100 milliseconds to 500 milliseconds, so that's from vCenter to the host, but I've kept the bandwidth constant. Okay? As you can see, even though we've increased the latency substantially by 4x or 5x or whatever, we haven't increased the latency by 4x or 5x. It's not like there's a linear relationship there, but there is a relationship. Okay, and the other charts, in which I basically gradually decrease the throughput, you'll see that the throughput has a lot less of an impact on performance than the latency appears to. And we have a white paper on this, which is due for a refresh. It's about robo. But the bottom line is, if you have a nickel to spend, our experiments have suggested that latency seems to have a bigger impact on performance than bandwidth. And again, it's not linear. If you made the network 10 times longer, the operations would not be 10 times longer, but it has an impact. Okay, a lot of times I get questions about how many concurrent operations I can do in vCenter. The hard and fast rule is that I can do up to around 600 concurrent operations at 600 operations at one time before any other request that I have gets queued. vCenter has a hard limit of 2,000 concurrent sessions. So 2,000 people can log in, or I can have 1,000 people log in and have 1,000 remote console sessions. The point is, at 2,000, vCenter will stop accepting inputs, stop accepting logins. So those are the vCenter wide limits, but you have to have a little bit more nuance to this. We also have per host and per data store limits. A host can be involved in up to 8 provisioning operations at a time, and I'm defining a provisioning operation as a clone, a vMotion, or a relocate. Okay? And I'm going to get into the next point on the next slide, so I'm going to save it. A data store can be involved in up to 128 vMotions at a time. So by the way, the first point is why when you do a bunch of operations against vCenter, you might see only 8 at a time, because maybe it's going to the same host. So a data store can do 128 vMotions. A data store can do up to 8 storage vMotions at a time. So if you've ever tried to do storage vMotions, you want to evacuate, that might be what's limiting you there. And you can change these limits. They're not officially supported, but why that's relevant is that if you come to me and say, hey, you know what, I have this particular subsystem and I can do this, can you guys please, for your next release, think about upping these limits? If I have that kind of information, I can go back and try to see if it can be changed. One final thing I wanted to point out. If you're using a 10 gig NIC, we allow you to do 2 times more vMotions on that NIC than if you have a 1 gig NIC. Okay, so the type of NIC that you're choosing influences your ability to evacuate hosts, and we have settings for that. Let's talk a little bit about the per host limits briefly. If I'm going to do a clone of a VM from host A to host B, what happens is that host A is charged 1 unit. Okay, host B is charged 1 unit. Remember, each host can be involved in up to 8 operations. So each of these hosts can be involved in 7 other operations. Okay? Let's contrast that if we clone a VM from a host to itself. When you clone a host to itself, it's charged because it's the source, it's charged because it's the destination. So its cost is 2, which means now it can only participate in 6 other operations. I'm telling you this because in a lot of VDI deployments or other deployments, people tend to put maybe 1 copy of a template on 1 host, and then they use that to clone to every other host in their system. You are automatically limited to 8 clones at a time if you do it that way. What's better from a concurrency perspective is to create a number of different templates and split them onto different source hosts, and then if an option, try to split those and clone them onto different destinations. That's how you'll get maximum concurrency out of vCenter. Okay? Now, from an API perspective, I just give one quick example that we have a lot of cool APIs. They're easy. Sometimes they're easy to use, and unfortunately, sometimes they can have an adverse effect on vCenter. I'll give you one example here. Many people use Power CLI. When I use the get VM call, it gets all the VMs from my server, and then it filters that VM list at the client to tell me the information that I want. So if I do a command like get VM with the names of the 4 VMs that I care about, this gets every VM in the system, and then on my client side, it filters out the information for those 4 VMs. So far, so good. If I change my code a little bit to specify each VM individually, this is much, much worse, because what you're doing now is you're getting the information for every VM, throwing it all away for the VM that you want, and doing that 4 times in a row. I put this example up here because sometimes I see these kinds of things in blogs or whatever, where people write PowerShell code. Just be mindful of what your API calls are doing to your underlying system. Okay? So, finally, let's talk about the impact of adding different solutions. So I'll give you an example of VROps. So, in vCenter, the default way that statistics work is that you grab statistics from your hosts and you persist them to the database. So there's a cost on your host and a cost in vCenter. When you add VROps to the mix, what you're doing is adding additional calls to get traffic, to get statistics from vCenter, and those commands get redirected directly to your hosts. Okay? And so what you end up doing is adding a cost in terms of CPU and network bandwidth on your host. You're adding a cost in terms of CPU and network to vCenter. And as an example at scale, I'll give you some numbers here where the data, when you attach VROps, the amount of data that you're grabbing now can increase between 4 and 7x. Like I said, our network demands are modest, so this is typically okay, but I'm just pointing it out. And in an extremely, extremely high churn case, this had an impact in our setup of about 20% throughput on vCenter. So we would have had to increase the amount that we provisioned to vCenter to accommodate this increased load. If you attach something like NSX, its impact has more to do with the vSphere web client. You want to make sure, we've tried to tune that heap size, but you may have to increase it if it doesn't match your environment. For something like VRA, the more workflows that you're doing at a time, the more load it's putting on vCenter. Okay? And the final bullet point in the performance section is that the bottom line of this slide, for small size, for large size, medium, whatever, on the x-axis it's the inventory size, y-axis operations per minute. Windows and the appliance have performance parity. So performance should not be the reason that you don't upgrade, that you don't use the appliance, excuse me. From the web client perspective, make sure your browser has 2 vCPU and 4 gig. If you have faster CPUs, you've tuned things so that you can take better advantage of that. If you can, use a browser in the same geography as your infrastructure. Maybe use a jump box and an RDP session instead of doing it over a VPN from far away. And make sure the heap size is okay, but we've tried to tune that, so you should be okay. Okay? So we're going to do a quick breeze through of some different deployment strategies. I hope that I've convinced you that performance should not be the reason that you move to multiple vCenters. Hopefully there are other reasons. Clearly your mileage may vary. There are a lot of different deployment options we have. Everything in one place except for the database, everything in one place except for the database and maybe a platform services controller for SSO, a bunch of different vCenters with external PSCs. I'm going to go into each of these in a little bit more detail. The big bottom line is whether you use one vCenter or many vCenters, now your SSO is on your platform services controller, and SSO is now handling link mode. It's called enhanced link mode. You no longer need a Windows-specific technology to link vCenters. That's all handled with SSO. Okay? And you're sharing roles, permissions, etc. So if you're fully embedded, like I said, we recommend to put everything in one box as long as it's fully resourced. Another popular configuration is putting the database separately. Fine. If you're going to use an external PSC, one reason I would recommend this is if you're planning to have multiple vCenters, you're probably going to have to want to share a PSC anyway. So it's best in a situation where you're going to have multiple vCenters, put the PSC externally, and the out-of-the-box settings for the PSC should work just fine. Now, like I said, for many of you, you still have some sort of limit where I want to only put this many operations per second on a certain vCenter. I only want to have a single vCenter manage this many hosts, these many VMs. That's fine. For other of you, you use multiple vCenters because of separating lines of business or whatever. You might also use it because you have multiple geographies. The bottom line here is that for you, you've gotten a lot of information about how to decide when to use one or multiple vCenters. Now the decision is how you deploy your SSO. If you're using a single PSC, then you share roles and permissions across everything. You share licenses. A lot of this, the roles and permissions is new in 6.0. That's awesome. With a situation like this, where you just have a single PSC, however, that introduces a single point of failure. So the recommended configuration in a setup like this is to actually include a load balancer. And with this load balancer, you automatically get failover capabilities, etc. And there is a stated limit of 8 vCenters per PSC pair. That should be just fine. But otherwise, you still get your role license, etc. replication. If you're in a multi-site configuration, you can have a PSC on different nodes. They will replicate, basically PSCs replicate to one another about every 30 seconds. So when you change something, you can expect that change to show up every 30 seconds. So this is how you would use a multi-site configuration. Now, still you're going to get roles, privileges, licensing, single pane of glass, but you're not going to get high availability in this case. On each site, you need some sort of load balancer to get high availability within the site. And if your local PSC goes down, you'll have to think about repointing it to the PSC on the other node if you don't want to stand up a new one. And honestly speaking, out-of-the-box settings for PSC should be just fine. I don't need to go over this slide. To conclude, 6.0, we've done a lot of work to make its out-of-the-box performance superior to 5.5, both in terms of the amount of operations per minute that you can sustain, as well as web client performance. In addition, we've done some vetting on the platform services controller. That's good for availability, and its performance out of the box should be just fine. Make sure that you give vCenter sufficient resources. Now you understand, I hope at least, some of the factors that influence that and how you should partition resources, whether it's churn, inventory size, or stats level. And these might change as you add more and more extensions. Finally, the appliance is fully, it's got performance parity with Windows, so if you're looking for an excuse to use the appliance, use performance, why not? And with that, I'm available for questions, and I should point out if we run out of time, I'll be available outside for any questions as well. There's a lot of other sessions that have to do with performance. I've listed them here. Please fill out the survey if you can, and I'm just going to leave it on this slide right here so you have some information.